Uh, Hello, my dear students. Hope you are keeping well. And today we are here to discuss some typical organic name reaction. What? Some typical organic name reactions. And these name reactions are very important. Very important after your class 12 and in different entrance exams. It may be any engineering entrance exam, any medical entrance exam, any architecture entrance exam, or in any other universities entrance exam, any other colleges. Okay, so though it is little bit difficult for the students who are preparing for only board exams, because board exams usually don't give such typical questions. Okay, but I assured my dear students, if you practice these reactions, you must be benefited. These reactions are very beneficial for you to solve the typical questions asked in your entrance exams after plus 2. So let's start. And before going through the class, I must request all of my dear students to please subscribe my channel so that I can get in front of you some more important classes. Okay, and if you do have any queries, any askings, any questions, please drop your queries, your askings, your questions in the comment section so that I will get your questions and doubts, and I must solve your problems. Okay, I assured you. And again, if you want to uh, get the PDF formats of my classes, write down in the comment section. I'll provide you the PDF free of cost. Okay, and one thing, please keep your notebook handy. Keep your notebook handy. Chemistry without practicing in notebook is big zero. Okay, I repeat, chemistry and in other subject also, without practicing in notebook, a big zero. So you should practice in the notebook and you should write down all the things I am going to write on the whiteboard. Okay, by pausing the video. So let's move. So today, some typical name reactions. So first of all, benzoin condensation reaction. Benzoin condensation reaction. Benzoin condensation reaction. Okay. So what is the benzoin? What is benzoin? So what is benzoin? What is benzoin? Benzoin actually is nothing but a alpha hydroxy ketone. Alpha hydroxy ketone. Alpha hydroxy ketone type dimer. Alpha hydroxy ketone type dimer. Alpha hydroxy ketone type dimer. Okay, like this. This is the dimer. So this is a benzoin. This is a benzoin. Okay, this is in with respect to ketone. This is alpha carbon, and this is the dimer of 2 benzene. Dimer of 2 benzene. 2 benzene ring, and one hydroxy group is present at the alpha carbon with respect to this keto carbon. Okay, so this is the dimer of benzene ring. So how this happened? So this I like to write down the definition. The self catalyzed the self catalyzed condensation reaction, self condensation reaction, not catalyzed, the self condensation reaction. Self condensation means condensation between two similar type of aldehydes. Okay, so the self condensation reaction between two same aromatic aldehyde, should be aromatic, between two same aromatic aldehydes. The self condensation reaction between two same aromatic aldehydes catalyzed by catalyzed by cyanide forming an aromatic dimer with alpha hydroxyketone, alpha hydroxyketone group, ketone functional group, known as benzoin. So this is the benzoin condensation reaction. Let's example. So this is an aromatic aldehyde. All of we know this. This is the aromatic aldehyde, benzaldehyde. And two benzaldehyde molecules condense in presence of cyanide ion, acts as catalyst. This is a reversible reaction, and this will form the benzoin. So this is the benzoin condensation reaction. Write down the notes. Okay, write down the notes. By pausing the video, please write down the notes. Next, next, we going to discuss the mechanism of the benzoin condensation reaction in brief. We will not discuss the detail of the mechanism. Only the required part we will discuss. So, mechanistic pathway. What are the mechanism? So, at first, one benzaldehyde molecule. This is the cyanide ion. It donates the electron here, and all these things, all these parts are reversible reaction. Please follow the reaction. You can easily understand. You can easily understand. I'll write each and every portion. Okay. So this negative charge here, the negative charge accumulate uh, easily can be resonance stabilized. Okay. So next, another benzaldehyde molecule comes in the picture. Again, now what happened? Mm, the CN portion actually, the CN portion becomes like this. And this is the benzoin. So look, in the whole mechanistic pathway, one this moiety, this aldehyde gives electron to this aldehyde. Okay. So the aldehydes between the two molecules of the aldehydes, which one first reacts with the cyanide, act as the donor, because this this species try to follow my notes. This species gives electron to this aldehyde. So this aldehyde is the donor and this is the acceptor. So this is the donor molecule and this is the acceptor. And what happened finally? The donor the donor molecule becomes ketone. Okay. This oxygen becomes ketone, and the acceptor ketone moiety becomes aldehyde. Okay. And the donor first reacts with the cyanide. So the molecules which first reacts with the cyanide, that part becomes ketone, and the acceptor part becomes aldehyde. And because this choice and this selection is very useful when the two aldehydes are different. If the two aldehydes are same, here in case of the two benzaldehyde, the two aldehydes are similar, then the questions does not arise. The question of acceptor, which one is acceptor, which one is donor, is not arise. But when the aldehydes are different, then the selection must be done. Okay. Then you should know properly which one is acceptor, which one is donor. And we will give some example of the two dissimilar molecules of aldehydes, like this. So Example, NH2. So what will be the result? If the reaction is done, if the reaction is given, if this reaction is given in your exam, it will be asked to write down the product. So my question is, what will be the product? So look, which one act as the aldehydes are different. These aldehydes are different. So between these two aldehydes, two aromatic aldehydes, which one acts as donor and which one acts as acceptor? Okay, you can easily see that the nitrogen atom has the two lone pair of electrons. So this lone pair of electron actually enhances electron density on this benzene ring. So between the two aldehydes, this benzene ring acts as the donor. This benzene ring acts as the donor, and this ring acts as acceptor. And we all know the donor part first reacts with the cyanide, and that part in turn at the last stage becomes what becomes the keto group. So without going through the detailed mechanism, we can write down the product very easily. That means it is true that the reaction is the Benzoin condensation reaction, and the donor part, why it is donor, because the nitrogen atom attached at the para position enhances electron density on the benzene ring. So this benzene ring acts as the donor and this acts as the acceptor. So the donor part becomes ketone. The donor part becomes ketone and the acceptor part becomes aldehyde, becomes hydroxy. Okay. So it is a very useful example for the two dissimilar. Next example. This is known as furfural. Furfural. This is known as furfural. When it given to cyanide, it becomes. So this is the two similar aldehydes. So no question arises which one acts as the acceptor and which one acts as the donor. We can easily write this. Okay. So this is known as furine. This is known as furine. Okay. Try to write down. Try to write down. I again request you. Try to write down the notes. Okay, my dear friends. Next, we'll see another name reaction here. And here again, we'll not discuss uh, the Knoevenagel reaction. The Knoevenagel reaction. Knoevenagel condensation. Previous was the Benzoin condensation, and this is the Knoevenagel condensation reaction. The Knoevenagel condensation reaction. What happened? I must write first the keto group, the ketone reacts in the active methylene compound this is the methylene hydrogen, this is the methylene carbon, and this is the active methylene compounds. Okay, and the x and y, what are the x and y? The x and y are the two electron withdrawing moieties, electron withdrawing center. When reacts with the base, what happen? It acts as the like this. An alkene will be formed. Okay, an alkene will be formed. So this is the base catalyzed, the base catalyzed aldol type condensation reaction, the base catalyzed aldol type condensation reaction between a carbonyl, between a carbonyl compound, between a carbonyl compound, usually the carbonyl compound, usually without any alpha hydrogen atom. The carbonyl compound without any, the carbonyl compound should not have any alpha hydrogen atom, usually without alpha hydrogen atoms, a compound and a compound containing active methylene group and active methylene group is called Knoevenagel condensation reaction, is usually called Knoevenagel condensation reaction. So write down the notes, my dear students. Now what are the x and y? The x and y are the two electron withdrawing pieces. So what are the electron withdrawing pieces? Electron withdrawing pieces can be of similar type, can be of nitrate, cyanide, COR, okay, COPH, COOET, etc. As for example. Okay. So we are going to see some example. We are going to see some example. So like this example, if it is given benzaldehyde, this is a benzaldehyde and carbonyl compound without having any alpha hydrogen atom, because the alpha carbon atom does not have any alpha hydrogen. Okay, so benzaldehyde molecule, this is the CH2 and this part COOET. So look, so this is the active methylene group. Why it is active methylene? Because the methylenic carbon is attached with the two electron withdrawing pieces COOET, here as COOET. So when it is treated with the base, what happen? Simple It is Knoevenagel reaction. It is Knoevenagel condensation reaction. C C C O O E T COOET. This is the form, and when it is hydrolyzed, if it is heated with H3O plus, it gives CH CH C double OH CH C double OH alpha beta unsaturated carboxylic acid alpha beta unsaturated carboxylic acid alpha beta unsaturated carboxylic acid. Okay, so my dear students, you have seen two very important name reaction. Basically, the two reactions are condensation type. One is benzoin condensation and another is Knoevenagel condensation reaction. Hope you all enjoyed this class, and also I earnestly request my dear students to please subscribe my channel. If you subscribe my channel, I'll be motivated. Once again, I repeat, I'll be motivated. Okay, so please subscribe my channel, and if you have any queries, please write down in the comment section. Okay, and keep keep watching and keep learning, and while learning, write down the notes. Okay, so goodbye. Once we all meet in the next class, till then, have a good journey.